Related rate problems. Related rate is the rate with respect to time. Okay, so what it is d over dt. Okay, so it could be dv over dt if we're talking about the volume is changing at the rate, or dr over dt when we're talking about the radius is changing at a rate. So let's take a look at an example. Okay, so a spherical balloon is inflated at a rate of 11.5 cubic centimeter per second. So what is this rate telling us? It's telling us, or given to us, the volume dv over dt is changing at a rate of 11.5 cubic centimeter per second. Okay, at what rate? So what is asking is at what rate the radius is increasing. So dr over dt. Okay, what is the rate? When, so it's given when r is 1 cm. So in order to solve our related rate problem, we need to relate the quantity that we're talking about. So we need to relate the volume with the radius r. So its volume is 4 over 3 pi r cubed. And how do we relate the rate? Well, we have to take the derivative with respect to time. So take the derivative of the volume, dv over dt, is just that. The derivative with respect to time of the right-hand side, right, it's just 4 over 3 pi, that's a constant, times r to the third power, so power rule, right? 3r squared, but r is a function of time, so it's dr over dt. Then you can simplify and solve, right? So dv over dt is given is 11.5. And the right-hand side, you can simplify it to be 4 pi r squared times dr over dt. So dr over dt is really 11.5 divided by 4 pi r squared. And if you want to solve for r equals 1, just plug in r equals 1 and simplify, or use a calculator to get the numerical answer. So that is one way to solve this related rate problem.